We are continuing to solve quadratic equations by graphing, but today it's with approximations. Not always will your answers be perfect numbers. Sometimes we have to round our answers to the nearest tenth or so. Our numbers here turned out to be perfect right on the line, but sometimes our parabolas might not end up perfect, and we have to find out what these two places are in terms of our answer. We won't do it by factoring. We will do it by graphing. Approximating zeros of the quadratic function, let's go ahead and use this equation, and we're going to round to the nearest tenth in the end. Remember, this f of x that is up here means the same thing as if I had a y equals, okay, or if there was a 0 equals. It all means the same thing. We are going to graph the quadratic equation. X is equal to a negative b over 2a, so we will have x equals a negative 2 over 2 times 1. In other words, x is negative 1. Let's go ahead and make ourselves an xy table, and we're going to put a negative 1 in for our vertex. When we substitute a negative 1 in and square it, plus 2 times the negative 1 minus 4, we find out that y is going to be equal to a negative 5. That is our vertex. 1, 2, 3, 4, 5. We have our vertex starting there on our graph. Let's put a 0 in. The 0 works out very nicely. That'll be a negative 4. Let's check to make sure we have the right vertex by putting in a negative 2 into our equation. Negative 2 squared plus 2 times negative 2 minus 4 equals y. That's 4 minus 4 minus 4 equals y. The first two 4's cancel out. We find out that y is a negative 4. That's what we were hoping that it would be. We need to keep going through until we find that y is equal to 0. And so I will go to a positive 1, and that means that I need to use a negative 3. When you put your numbers in, you find out that these are both going to be negative 1. And we're still not at 0, so now let's go to 2 and negative 4. This time when we put in the 2 and the negative 4, we find out that we've now jumped to a positive number. We've jumped to a 4, and this will cause us now to look at our problem and say, what about the numbers that are in between a couple numbers here? So we have our graph going like this right now, and we know that somewhere between negative 3 and negative 4, and somewhere between 1 and 2, we know that it will cross the x-axis. But where is that point? Well, we want to go to the nearest tenth. So we're going to make ourselves another xy table. This one's kind of long. So I'm going to put it down here. I'll put 1 in and negative 1. And I'm going to put the 2 and the 4 on the other side. What I am doing here is I am looking at this section of my number line between 1 and 2. So I'm starting to put in some numbers like 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, and 1.9. Now technically you can go through and find every y value for each one of those. In fact, I have all the y values for each one of those. And you can see that these y values are pretty positive over here. We get down to 1.25, but they're starting to get smaller and smaller along the way. And here, it just turned into a negative number. Please notice, as we are looking at these two numbers right here, 1.2 and 1.3, where we jump from a negative number to a positive number, what you have to consider is which one of these two y's is closer to 0 in terms of distance. Negative 0.16 or 0.29. hopefully you realize that this negative 0.16 is closer to the y to 0 than 0.29 is. So therefore we are going to choose 1.2 as our x. That's one of our x's. So we have 1.2 right here, 1.2 comma 0. And when you look at this, I went 0.2 of a unit to the right of 1. Or if you think about the axis of symmetry, we went 2.2 units to the right. That means I need to go 2.2 units to the left. And that gets me to the point -3.2. Those will be my two approximations for our zeros of this function. You have to look carefully at which one of the y's is closest to 0. And whichever one is closest to 0, the corresponding x is the x that you want to use. Good luck on your homework.